Okay, so for Algebra 1 today, we're in Chapter 9, Section 4. We're moving away from multiplying, and we're going to start talking about dividing or factoring, okay? So we are beginning with what is called the zero product property. If I multiply a series of factors together, and one of those factors is 0, what happens to the product? Zero. Okay? So that's what it comes down to. When you multiply a series of factors, if one of them is 0, your product will be 0. Okay? But there's more to it than that. So we can also say, let's say, okay, if AB equals 0 as a rule, then what could you say about A? Kyle? If A times B equals 0, then A could be, it could be something else, but it could be 0. Either A has to be 0, or we would say B has to be 0 in order for that to be true. Now, we've started working with factors that are not just a single number. They're binomials, right? So this is where it gets tricky, you'll see today. So when the equation equals 0, let's do it this way. When an equation equals 0, like up here, this equation AB equals 0, then either A is 0 or B is 0, right? So we call the solutions of the equation the roots, okay? And notice in the word roots we have little zeros. Actually, they're O's, but they look like zeros. So as we're moving into quadratic equations and factoring them, the word solutions is interchangeable with roots. Solutions are the answer when you set the equation equal to 0. I'm only going to say that 5 million times for the rest of this year. Anyway, you'll hear it. Okay. So let's use the zero product property. So here we have, as I said, more sophisticated factors. We have two factors. They're binomial factors. So if this equation equals 0, we're trying to find the possible solutions, right? Let's look at the first binomial. Or let's look at this entire thing. We've got two factors, so one of them has to equal 0 in order for this to be a true statement, right? We have two possibilities. What would make this first binomial equal to 0? If I stick a 0, okay, it says 0. If I stick a 0 here, 0 plus 3 is not 0, is it? So what would make this whole binomial equal 0, Hank?
-3.
-3, right. So your one solution, or one root, is -3. And the other one is? What would make the second binomial? 5. So really 0 is not a factor here. 0 is not a solution, okay? So either x plus 3 had to equal 0, or x minus 5 had to equal 0. So you're right, -3 would be a solution, and 5 would be a solution. Now, if I choose to input -3, I must input it into every x in this equation, right? So if I plug in -3 here, I would have -3 plus 3 times -3 minus 5. What is -3 minus 5? -3 minus 5 is? -8. So it doesn't matter that that second term is -8, because what is the first term equal to? 0, so it wiped it out. Okay? But keep in mind, when you plug an x value in, it's going to be one value plugged in to all of the x's for that equation. Okay, so let's try it again here. What values, and shh, quiet, let everybody think. What are the roots of this equation? Or what are the solutions of this equation? So you would say, what would make this true? Or what would make this true? And Oscar, what do you have?
5.
Could equal 5, or it could equal 1. Good job. Everyone understand?
Yes.
Okay, does it get a little trickier? Yes. Look at this. This is binomials that have a little more going on. Again, either 3x minus 1 needs to equal 0, so go solve it. Right? Takes you back to 6th grade. or 4x plus 5 equals 0, and solve it. Just a little two-step problem, isn't it? And how about the first one, Matthew?
X equals 1/3.
1/3, good. And that's because we would add 1 to both sides, and then we would have 3x equals 1, and then divide both sides by 3, right? Just a little two-step problem. How about the second solution? Okay,
X equals 5, or
you would subtract 5,
Oh, yes.
right, from both
Oh, yeah.
sides, and you would have,
4. Oh yeah, so we can do
and I think you're saying it backwards, it would be negative
it.
5.
Negative 5.
Of course, good. Okay, does everyone understand how we got those solutions? Or roots? Okay, next we will find the greatest monomial factor. Okay, so we're going to begin finding the smaller factors of a bigger polynomial. Okay, so factoring. Factoring is something that you're familiar with, factor trees from the past, right? It is finding, writing, in this case, the polynomial is not, doesn't look like the trinomial, let's say. It looks like multiplication of a binomial and a monomial, or a trinomial and a monomial, or maybe two binomials. It looks like what you were given earlier in this chapter, and you had to FOIL it, or you had to distribute it, right? And get a simplified expression. So a polynomial written as a product of its whats? Factors, good, factors. Okay. So we're looking for the GCF, greatest common factor of the terms. So we're going to try about 4 of these. So looking at example A, you're looking at both terms, and well, first, could you combine these terms? 8x plus 12y? No. It's like 8x plus 12.
Used oranges in our last year.
Yeah, these are so different. I wouldn't use iPad and iTouch, right? I would say like,
Oranges and apples.
okay, oranges and apples. 8 oranges, 12 apples.
Oranges and bicycles.
Okay, yeah, oranges and bicycles are so different. So, we cannot combine them. So, what factor do they both have in common? 4. So we're going to do this. We're going to say 8x plus 12y could be written as 4 times. What would I have to multiply 4 by to get back to 8x? To what? To 2x, right? Plus 3y. Good. And all you have to do is think about distributing it, right? And you get right back to the original. If you have factored correctly, you can multiply it right back to the original, right? So you certainly can test your answer. See if it's right. Okay, that's it. That's the factored form. That's it. Okay, let's try this. Shh. Everyone on your own, and we'll say it together. 14m plus 35n. Okay. So Ellie, what do they have in common?
7.
Okay. So let's say together 7 times
2m plus 5n.
Good job. Easy, easy, good.
So do you have to write the first number?
One more. This is a little more sophisticated. Now, these are not like terms. One is not squared and one is. So it's like, what did we say? An iTouch and an iPad. These are totally different things, okay? So now, they do have a lot in common though. They both have y's, right? So that's a common factor, isn't it? So see if you can pull up what is the biggest common factor. Haley, what number can go into both of these? 7, okay. And what else can go into both of these? They both have, at least what? Madeline? 1y, right? So we can pull a 7y out of both of these. 7y times what gets us back to 14y squared?
2y squared.
No, 2y, right? If you say square, then when you would multiply these, you get a cubed answer, right? Plus 3. Good job.
You deserve it. I have 2 cameras.
Okay, so this is your assignment. It shouldn't take you too long to
Feel
complete
that,
this.
Sandra?